Good evening, dear students. Today we will be discussing, the questions, few questions from pair of straight lines passing through the origin. If you recall, in the previous session we discussed about, pair of straight lines in details, its theory, and also we, complete a couple of questions. Now, in this session today, what we'll do, we will do some more problems, and which will make sure that our understanding on pair of straight line passing through origin is, is good. So, before I proceed, just a formality. Could you please confirm that you are able to hear my voice very clearly and able to view the screen properly? Could you please, couple of you, please confirm?
Yes, sir.
Okay, great. Fantastic. So, we discussed in the previous session two questions. Here is the third question. So here's the questions, says that, so that the equation x square plus 3xy plus 2y square equal to 0 represents a pair of straight lines. First is this thing. Then we need to find those straight lines and the angle between them. So now, dear students, the given equation is a homogeneous equation of second degree. And we know that homogeneous equation of second degree always represents a pair of straight line passing through the origin. Correct? That's what we understood from the theory. So hence this is the proof that as the given equation is a homogeneous equation of second degree, so it represents a pair of straight line passing through the origin. Now, if we just look into this equation, that x square plus 3xy plus 2y square equal to 0, what we can write from here? We can do factorization. So if we do factorization, so what we're going to get is that x plus y into x plus 2y is equal to 0. X plus y into x plus 2y equal to 0. That implies what? That implies, x plus y equal to 0. So this is one straight line, and x plus 2y is equal to 0. This is another straight line. So these are the two, straight lines. Correct? So that is the, the first part of the second portion of the question. Second portion of the question is that find those straight lines. So the first straight line is x plus y equal to 0. And the second straight line is x plus 2y equal to 0. These are the equation of these two straight lines. And now we're going to find what is the angle between them. And I will appreciate, dear students, you also do along with me. Open your notebook, do along with me. Now, to find the angle between them, we need to know their slopes, and it is pretty simple to find the slope. If we find the slope of the straight line x plus y equal to 0, then MO as M1. If M1 is the slope of the straight line x plus y equal to 0, then obviously M1 is equal to minus 1, because that is the coefficient of x in the right hand side. So what I am saying is that x plus y equal to 0 means what? Y equal to minus x. Hence the slope of this straight line, if we assume as M1, if we symbolize as M1, then M1 is equal to minus 1. And from here what we can write? Y is equal to minus 1 by 2 into x. So that implies what? If we assume that M2 is M2 is denoting the the slope of the straight line, second straight line, then M2 is equal to minus half. Now if we assume the angle between them is theta, okay, then what is tan theta? If we assume the angle between them is theta, then tan theta is equal to tan inverse, tan theta is equal to M1 minus M2 by 1, There are two ways we can find it out. One is that we can find it out from that m1 minus m2 by 1 plus m1 m2. That we can find it out. What is that? That route, if we can go, if we apply that one, what we can going to do is that tan inverse of m1 minus m2 minus 1. So what I'm saying is that tan theta is equal to mod of m1 minus m2 divided by 1 plus m1 into m2. And what we are going to get it from here? So this implies tan theta is equal to mod of m1 is minus 1, m2 is minus half, so minus of minus half is actually plus half, divided by 1 plus m1 into m2, that is 1 by 2. So that becomes minus 1 by 2 by 3 by 2, that is actually equal to 1 by 3. So from here we find the value of theta is equal to tan inverse of 1 by 3. We can use this approach. Also another approach we can use, the angle between them from that equation itself. Means if I use a different color, dear students, that equation is what? X square, the pair of straight line joint equation, the homogeneous equation, plus 3xy plus 2y square equal to 0. If you resemble with ax square plus 2hxy, ax square plus 2hxy plus by square equal to 0. So what we get, dear students? We get a is equal to 1, h is equal to 3 by 2, correct? And b is equal to 2. So if the angle between them is theta, then also you can find that theta is equal to tan inverse of, if you remember the formula, 2 into square root of h square minus ab by a plus b. That is 2 into square root of h square minus ab. That means 3 by 2 whole square minus ab minus 1 into 2 divided by a plus b, that is 1 plus 2. So from here what we are going to get is that if you simplify it, then also you will get tan inverse of 1 by 3. So there are two ways you can find it out. So that is equal to tan inverse of 1 by 3. So I hope it is absolutely clear, dear students. At any point, any difficulty, never hesitate to let me know about it. Now we will move to the next question. Next question is going to be available to you in another few seconds. So next question, that is question number 4. As you see in the screen, it says that prove that the equation of the straight lines through the origin, each of which makes an angle alpha with the straight line y equal to x, is x square minus 2xy sec 2 alpha plus y square equal to 0. Okay. Now let's visualize this particular problem to understand that exactly what is meant by that. Okay, so for that let us first draw the coordinate axis. That is the most important part to draw. So let me draw it here. So this is x dash, y dash, and origin. So prove that the equation of the straight line through the origin. So what is the equation of a straight line through the origin? Each of which makes an angle alpha with the straight line y equal to x. So let us first draw the straight line y equal to x. So straight line y equal to x, dear students, it will be something like this. Let me draw properly. So straight line y equal to x will be something like this. That is the equation y equal to x, right? Now we need to find the equation of the straight line through origin, each of which makes an angle alpha with the straight line y equal to x. So what will be the orientation of those straight lines? So the first one should be something like this, which makes an angle alpha with this one, right? And the another straight line, if I draw it in the green color, will be something like this, correct? Did I draw it properly? Correct. That means what? According to the question, and what we can see is that this angle is alpha, and this angle is also alpha. Correct. What we need to find, dear students, we need to find the joint equation of the green straight line and the blue straight line. And the yellow straight line is the straight line y equal to x. So if L1 is the straight line, if you see, I should draw it in a different color so that you make it absolutely. So this angle is alpha, and this angle is also alpha. Suppose that blue straight line is denoted by, symbolically by L1 and the green one by L2. Then both the straight line L1 and L2 makes an angle alpha with the straight line y equal to x. Correct? Then we need to find the joint equation of L1 and L2. That means we need to find we need to prove it. It is already given us that you need to prove it. The pair of straight line represented by L1 and L2 is x square minus 2xy sec 2 alpha plus y square equal to 0. How to do this thing? Now, one thing, it is pretty simple. That straight line y equal to x makes an angle pi by 4, right, with the x-axis, because its slope is 1. So this angle is pi by 4. So what I'm saying is that this angle is pi by 4. If this angle is pi by 4, then the straight line L1 makes an angle pi by 4 minus alpha. Correct? And the straight line L2 makes an angle pi by 4 plus alpha. I hope it is clear to all of you, right? That the straight line L1 makes an angle pi by 4 minus alpha, and the straight line L2 makes an angle pi by 4 plus alpha. So what will be the equation of L1? Y equal to mx. Mx means what? Tan of pi by 4 minus alpha into x, because the straight line L1 passing through origin with slope tan of pi by 4 minus alpha. The inclination of the straight line L1 with positive direction of x-axis is pi by 4 minus alpha. So its slope is tan of pi by 4 minus alpha. Eventually its equation is y equal to tan of pi by 4 minus alpha into x. In the similar manner, that L2, its equation should be y equal to tan of pi by 4 plus alpha into x. All you need to do is, dear students, is that we need to find a joint equation, that is a pair of straight line representing both. Correct now? So now let's look into y equal to, if we look into the L1, that is y equal to tan of pi by 4 minus alpha into x. So here you need to apply the concept of a trigonometric function, dear students. So let's apply the concept of trigonometric functions, and we will find it very we will achieve our result. So let me use a different color. The L1 was represented by the blue color. So let me derive this thing in blue. So from here what we going to get is that L1. So for L1 what we are going to get is that y is equal to tan of a minus b. So that is equal to tan a minus tan b by 1 plus tan a tan b. So tan of pi by 4, that means 1, minus tan b, that is alpha. Tan a minus tan b by 1 plus tan a into tan b. Tan a means what? Pi by 4. Tan pi by 4 is 1 into alpha. So 1 plus alpha. So this y is equal to this into x. So this is the equation of L1. In the similar manner, we can find the equation of L2. So how we can find the equation of L2, dear students? So in the similar manner, we can find y is equal to tan of a plus b, tan a plus tan b by 1 minus tan a tan b. So in the similar manner, we will get 1 plus tan alpha divided by 1 minus tan alpha into x. Correct? Now what you need to do is that we need to find the pair of straight line. Okay, therefore the required equation of the pair of straight line will be what? That required equation of the pair of straight line. So let me write it in red. So the required equation of the pair of straight lines is y minus, what we can write is that y minus 1 minus tan alpha divided by 1 plus tan alpha into x into y minus 1 plus tan alpha divided by 1 minus tan alpha into x, that is equal to 0. Now all we need to do is that we need to simplify. So you see that y and y will get multiplied, so it become y square minus, what we can get is that we get 1 minus tan alpha divided by 1 plus tan alpha plus 1 plus tan alpha divided by 1 minus tan alpha into x into y. Correct, dear students? And then what we get is that 1 minus tan alpha by 1 plus tan alpha into 1 plus tan alpha by 1 minus tan alpha into x square. So that will get cancelled, and ultimately we'll get actually plus x square is equal to 0. So x square plus y square we get. So then what we are getting eventually? So if we simplify further, dear students, so from here what we get is that y square minus, the denominator will be 1 plus tan alpha into 1 minus tan alpha, that is nothing but 1 minus tan square alpha, and in the numerator we get 1 minus tan alpha whole square plus 1 plus tan alpha, 1 plus tan alpha whole square into xy plus x square equal to 0. Correct? So from here what we can get is that 1 plus a minus b whole square plus a plus b whole square is nothing but 2 into a square plus b square, dear students. So what we get, y square minus, in the numerator we get 2 into a square plus b square, that means 1 square means 1 plus tan square alpha divided by 1 minus tan square alpha. Correct, dear students? Okay. So 1 minus tan square alpha. correct? One minus tan square alpha. Let me write properly. 1 minus tan square alpha into xy plus y square equal to 0. So now, if you remember that 1 minus tan square alpha by 1 plus tan square alpha is cos 2 alpha. So from here what we get? We get y square minus 2 into x into y divided by cos 2 alpha plus, oh I'm sorry, there's a small mistake I have done. This should be x square. A plus x square is equal to 0. So from here we get the required equation. We are able to prove it, that the equation, joint equation of the straight line, that means the equation of the pair of straight line, the way you want to say, minus 2xy into sec 2 alpha, 1 by cos 2 alpha is sec 2 alpha, plus y square is equal to 0. And this is what is given to us to prove. Correct, dear students? I hope things are absolutely clear. Any doubt at any point of time, never hesitate to let me know. Okay. If things are clear, dear students, so let's proceed to the next question. And the next question will be available to you in another few seconds. And here also we are going to prove something. Okay. Here the question is, if the pair of straight lines x square minus 2pxy minus y square equal to 0 and x square minus 2qxy minus y square equal to 0 be such that each pair bisects the angle between the other pair, then so that prove that PQ is equal to minus 1. Let us give a visual representation of this problem. So let me first draw the diagram. This is origin. Okay. So now let's consider that pair of straight line for x representing that x square minus 2pxy minus y square equal to 0. Okay. So obviously this is as x square minus 2pxy minus y square equal to 0 is is a homogeneous equation. So it represents a pair of straight line passing through the origin. So what are those two straight lines? Let us draw one in green color and one in blue color. So this is one straight line. Sorry, this is one straight line. Okay, and another straight line. So that I can draw in the blue color. Yeah. So suppose another straight line is something like this. Now, okay, let me give a different orientation. Suppose it could be something like this. Just a minute. Okay. So now, as you see these straight lines, as represented by the green and blue lines, actually it is represented by, that the pair of straight line x square minus 2pxy minus y square equal to 0. Correct? And what you need to prove, dear students? we need to prove that if the pair of straight lines, the bisectors, okay, of this pair of straight lines will be what? That green and blue lines, pair of, if we draw the bisectors, so one bisectors, it will be something like this. Sorry, one bisectors will be something like this, correct? Which is an internal angle bisector, and external angle bisector will be something like this, correct? So now what you see in the purple color and the in yellow color, these are the bisectors represented by x square minus 2qxy minus y square equal to 0, correct? Because that the pair of straight line which are the pair of straight line that are those are the bisectors of the pair of straight line represented by x square minus 2pxy minus y square equal to 0 are actually jointly represented by this equation that x square minus 2qxy minus y square equal to 0, correct? Now, what is the equation of the bisectors of the pair of straight line represented by x square minus 2pxy minus y square equal to 0? Okay, so what we can write is that the equation of the bisectors of the angle between the equation, let me use a traditional red color, the equation of the bisectors of the angle, equation of the bisectors of the angle between the pair of straight line, between the pair of straight lines, between the pair of straight line x square minus 2p xy minus y square equal to 0 is, what is going to be the equation? If you recall, that is x square minus y square divided by a minus b, that is 1 plus 1, that becomes 2, that is equal to x into y divided by minus b, correct? Equation of the bisectors of the, if you recall, the equation of the bisector is what? X square minus y square by a minus b is equal to x into y by h, correct or not? So let me, if you want to just have a quick recap on that, what I want to do mean is that if x square plus y square plus x square plus 2hxy ax square plus 2hxy plus by square is equal to 0. Just a minute. What I wanted to mean is that if x square plus ax square plus 2hxy plus by square equal to 0, that represents a pair of straight lines, then what is the equation of the bisectors? The equation of the bisectors is x square plus y square, x square minus y square, sorry, x square minus y square divided by a minus b is equal to x into y by h. And if we apply the same concept, we are getting it here, that for this one, what is the equation of the bisectors? X square minus y square by a minus b. A is 1 and b is minus 1, so a minus b become 1 minus of minus 1, that is 2. That is equal to x into y by h. What is h? H is nothing but minus 1. And that's why we write h is nothing but minus p. So we get minus p. Now, from here, what we can say, dear students? So from here, what we can write is that, this we can write is that px square plus 2xy plus and minus py square equal to 0. So this is a joint equation of the bisectors of the straight line, whose equation is this. Now, if you look into the question, this equation and x square minus 2qxy minus y square, that is equal to 0. If we see that x square minus 2qxy minus y square equal to 0, both are actually, identical according to the question. So then what we'll get? P by 1, the coefficient of x square of this equation should be and coefficient of x square in this equation, right hand side, p by 1, that should be equal to coefficient of 2xy in the left hand side equation, that is 1, divided by coefficient of 2xy in the right hand side equation, that is minus q, okay, should be equal to coefficient of y square in the left hand equation, that is minus p, and divided by coefficient of y square in the right hand side equation, that is minus 1, that again become p by 1. Now from here what we can say, dear students, we can say p into q is equal to minus 1, and that is what we wanted to prove.
Sir?
Yes.
Sir, I understand how we wrote px square plus 2xy minus py square, and that is identical.
Oh, okay. Thanks for asking your question. So if you look into this x square minus y square by 2, this equation, x square minus y square by 2 is equal to xy by minus p. Make a cross multiplication and then simplify, you'll get this.
Yes, sir.
That is. Now, if you see that, if you go through the equation, a question, if the pair of straight line x square minus 2pxy minus y square equal to 0 and x square minus 2qxy minus y square equal to be 0, be such that each pair bisects the angle between the other pair. You see that x square minus 2pxy minus y square equal to 0 is represented by the green line and the suppose L1 and L2, the blue line. Then what is their bisector? Their bisector is represented by L3 and L4, correct or not?
Yeah.
Then L3 and L4 is actually nothing but jointly represent this equation, x square minus 2qxy minus y square.
Yes, I understand.
Because each pair intersecting the other, na? And the converse is also true. So what I wanted to mean is that the bisectors of the straight lines L1 and L2 are L3, L4, correct?
Yes.
And bisectors of L3 and L4 also L1 and L2.
Yeah.
Correct or not?
Yes, sir.
So that is why we can make these two equations, identical, na? Understood?
Okay. Yes, I understand.
Oh, okay. So then we get, in this way, we are able to prove it that PQ is equal to, minus 1. Now, dear students, so next question, what we are going to discuss is something like this. Let me go to the next question. You'll be able to get it in another few seconds. Okay. Just about to share that question with you. So the next question, dear students, is here it is. Here also it is a proof that The question is that so that the angle between one of the straight lines given by ax square plus 2hxy plus by square equal to 0 and one of the straight lines given by ax square plus 2hxy plus by square plus lambda into x square plus y square equal to 0 is equal to the angle between the other two straight lines of the system. So first we need to understand the question. So if you find the equation of the bisector of this straight line, that pair of straight line x square plus 2hxy plus by square equal to 0. So what we are going to get? We know this thing x square minus y square by a minus b is equal to xy by h. Okay, so let's first write it down. The equation of the bisectors, the equation of the bisectors of the angle between the straight lines ax square plus 2hxy plus by square equal to 0 is, we know this thing, x square minus y square divided by a minus b is equal to x into y divided by h. Correct or not? Now let us find what is the equation of the bisectors, okay, of the angle between the straight line as represented by the second pair of straight line equation. So that means what you can write down? You can write down the equation. So I'm writing it here. The equation of the bisectors. The equation of the bisectors of the angle between the straight lines ax square plus 2hxy plus by square plus lambda into x square plus y square equal to 0. Now let us rearrange this equation a little bit, because we need to give into the form of x square together, then xy together, and y square together. So that is, if we write this thing, so it becomes a plus lambda into x square, correct, my dear students, plus 2 into h into xy plus b plus lambda into y square, that is equal to 0, is x square minus y square divided by the difference between the, difference means coefficient of x square minus coefficient of y square. That means what? A plus lambda minus b plus lambda, that is equal to x into y by h. Now if we see this equation, what we are going to get it actually x square minus y square divided by a minus b is equal to x into y by h. Now if you look into this equation and the previous angle bisectors of the first set of straight lines, pair of straight lines represented by this equation, what we see is that they are same. So we are able to prove that the angle between the straight lines given by ax square plus 2hxy plus by square equal to 0, okay, one of the straight line, and one of the straight line given by ax square plus 2hxy plus by square plus lambda into x square plus y square equal to 0 is equal to the angle between the other two straight lines of the system, and that is only possible if their bisectors equations are same. Correct, no, dear students? And this is the way we are able to prove it. Now, if everything is clear, then I can move to the next question, dear students. And the next question is something like this, and that is going to be the last question for today's session. And here it is. So the question here is that find the condition that one of the straight lines given by ax square plus 2hxy plus ba square equal to 0 may coincide with one of the straight lines given by a dash x square plus 2h dash xy plus b dash y square is equal to 0. Now, so what does it mean by this thing? So there are two pair of straight lines. That means one is that ax square plus 2hxy plus by square equal to 0, and another one is that a dash x square plus 2h dash xy plus b dash y square equal to 0. Correct, dear students? So these are the two sets of pair of straight lines. Now we need to find the condition that one of the straight lines given by the first pair of straight lines coincide with one of the straight line given by the second pair of straight lines. So let's take that common straight line be y equal to mx. Let us take that common straight line be y equal to mx. Correct? No? If we take that common straight line as y equal to ax, y equal to mx, then we can instead of um, uh, y, we can write mx in both the equations. Correct or not? Correct. So if we substitute mx for y in both the equations, so what we are going to get? So in this equation, if we apply that y equal to mx, that means wherever we get y, we are going to write mx. Okay. So what we are going to get? So y equal to mx. So we are going to get that ax square plus 2 into h into x into y is mx, correct, plus b into ms square into x square is equal to 0. This implies what? A plus 2h into m, a plus 2h into m plus b into m square into x square is equal to 0. But x square cannot be equal to 0, na, dear students. So what we are going to get? We are going to get a plus 2h into m plus b into m square is equal to 0. This we get one equation. Correct. Now, in the similar manner, in the same second equation also you can apply y equal to mx, as y equal to mx common to both the pair of equations. No? So what we are going to get in the similar manner, if we do that, we will get a dash plus 2 into h dash into m plus b into m dash square is equal to 0. Correct? So this is, we give equation number 2. Now dear students, if you look into both these equations and we start solving, I'm sorry, there is a small mistake I have done it here. Just a minute, it should be b dash m square, not b m dash square, b dash into m square is equal to 0. This is equation number 2. Now we can do cross multiplication of both these equations 1 and 2. So what we are going to get? We are going to get m square if you do the cross multiplication, that is equal to m square by a into h dash minus a dash into h, that is equal to m by b into a dash minus a dash into b, I'm sorry, both are same, b a dash minus b dash into a, that is equal to 1 by h into b dash minus h dash into b. Correct? Cross multiplication. Now from here you can find the required, sorry, there is another small mistake I made. It should not be m, it should be 2m. So it should be 2m. Now, if we can find the value of m square from these two, okay, and we can find the value of m between these two, and after that we can equate both these values of m, and then what we are going to get, the required condition is that you can do this work. I'm not spending time on that. Easy simplification here, which is out of context to this particular discussion. So it a h dash minus a dash h into h into b dash minus h dash into b, that is equal to b into a dash minus b dash into a complete whole square, and this is the required condition, dear students. This becomes the required condition. So dear students, one thing I would like to mention, this whatever the topics we are discussing this session and previous session, that is not there in your board examination, but it is certainly important for IIT joint entrance examinations. So that this is just for your information. So with this, I would like to conclude the class for today. In the next session, we will be discussing the pair of straight line not necessarily passing through the origin. If you have any question, please feel free to me. Otherwise, we can conclude the class here now. Thank you very much, dear students.
Thank you.
Thank you.